Alright, time for another DraftScience video presentation. Yeah, with sparkly bits. But this is actually a fairly good illustration of what I'm going to talk about, which is gravity. And the idea is stuff goes in, you can sort of see the stuff going in, and then stuff comes out. And the fact is that for matter, even electrons and protons, but more specifically atoms and things bigger than that, what goes in is a little bit more than what comes out in the sense of movement, the force, the stuff that makes things happen. So that's a subject in itself, this whole word force, and understanding that they do exist, things that cause effects, like the force of magnetism, and the force that could be called light. It's a force, it's an invisible thing that travels at the speed of force, and causes effects. And there's stuff that's doing that, and gravity is one of the things that's doing that. It's doing it at the speed of light. That's what it functions as, just like light. That's what LIGO would tell you, even though I don't think they're really listening to anything called the gravitational wave. The conventional physics understands that gravity moves at the speed of light. And I would argue it just simplifies things by just saying it's the speed of force, because all the forces, magnetism and gravity and light, all move the same speed. Alright, so that's probably enough of that. This could be irritating. I like it. Yeah, it's kind of nice. Alright, so we'll get to the subject of gravity and the cause of it. And this first thing everybody's got to sort of understand is we use the word gravity for something, and it's not really a something. It's an effect. It's not... the word gravity doesn't mean the thing that's causing gravity. And so this sort of goes back to the argument between this idea of doing classical physics versus Einstein physics or modern physics. And they'll use words like Newtonian when Newton overtly said he doesn't posit a theory of how gravity works, what's causing the effect. And yet they'll talk about it as if there's only two ways to understand it: the Newtonian way, which is not at all, or Einstein's way. And I'd say there's a third option. Yeah. Where you just go back to not positing and say, well, what if I was to posit? What would the possible posits be for a cause? And so then you just have to sort of go through the effects and figure out what would cause those effects. So I will pause. Alright, it should be back. So Einstein's theory of cause is to just basically describe the effect and state that there's a mechanism that's creating this idea of an inverse square law. So the idea is that in 3 dimensions you would have a force, a mechanism that's basically just saying, okay, understand the gravity well going in, right? So we take the classical idea of, bending an object sinks the fabric, and stuff will fall into the well created. But looked at on top, you could kind of get the idea that, well, yeah, that's really saying the same thing as there's this idea of convergence, that there's a pressure on the outside. This would be Mach gravity, for example, and it's just pushing objects, in towards the center. And so you can do this by sort of understanding, like Maxwellian drawings would just have a bunch of lines, and the idea would be as the lines are getting closer and closer together, and this would be some sort of mechanism for gravity, where you're just saying that if anything is on a line, it will fall at a rate proportional to the distance between the lines, and it just falls faster and faster the closer the lines get. But there's no mechanism, there's no force, there's no theory of anything going in or coming out that's causing the gravity. It's just some sort of idea that everything is bending space in these 3 dimensions and creating exactly, like I said, when it's taught, gravity is taught as Mach gravity, as this idea of an external fluid and a drain. The idea that there's pressure on the outside and it just keeps pushing things towards the center where it disappears, or whatever. The mechanism that pushed it anyway disappears. So understand that Einstein's theory isn't providing anything complete or a description of any kind of physical mechanism. It's just the idea that there's an inverse square law, and he's just inventing a magical mechanism that forces the convergence. So he escapes any obligation to account for the existence of, say, a force. If I was to say it was little particles, and I made the universe out of a bunch of little particles, and they all came in completely scattered positions. I won't use the word random, but yes, randomized. So they're just coming in from random places at random times. That would create a pressure around everything. Everything would be exposed to this pressure of constantly being jostled or hit. And their theory would be is that if you took 2 objects and put them in here, the fact is they'd end up moving towards each other because they would end up obscuring some of the force. A force going this way wouldn't be able to get to this object, and a force going this way wouldn't be able to get to this object, and therefore there would be an imbalance in the force. There'd be a lack of pressure here, and that would be enough to push them together, proportional to the inverse square law. So it creates the right mechanism. The negative consequence of that is that when something's moving with velocity through this field of stuff, the idea is that if it's moving in a direction, it's going to hit more of this stuff in front of it than it'll hit behind it, and therefore it's going to be dragged to a halt. Now, that can be fixed, but they don't even want to try to even imagine fixing it or coming up with an explanation. Even though there is some evidence in the face, glaring evidence, that electrons and protons, the elemental bits of matter, are in fact dragged to a halt. They don't keep going. All right, so gravity is an event, not itself a substance. So we're really trying to say, I'm saying it, yes, there is a substance that causes gravity, and you can call it force, the force of gravity, the force bits, you can call it energy. The idea is that this stuff exists. I would go further and say it's all the same stuff. It's the stuff that makes magnetism, and it's the stuff that light's made out of. Everything's made of this stuff. Now the catch is that there's 2 kinds of stuff proportional to the 2 kinds of matter, electrons and protons, and but we're not doing that part today. So, at least not yet. So sorry. All right. So the next, so it's just attempting to bullet point this subject. So I wanted to go through those. Whoops, went too fast. All right. Let's see. A force forces matter to move. So that's sort of the argument, that there's an actual thing in the universe. So this, I guess, is some sort of bold leap I have to expect from people to understand that there is all this stuff moving the speed of light. So in the category of moving, the speed of light, there's this whole bunch of stuff, right? The magnetism effects. Now, I wouldn't say there's an electric field, but let's say if you believe in electric fields, then, that's moving the speed of light. And then light's moving the speed of light. And then gravity's moving the speed of light. And all of these things are these little quantizable, Planchness to them kind of forces. I mean, they do come in discrete bits or clumps, as a Feynman would say. And that's sort of an accepted fact. And then you have this matter stuff, which moves much less than the speed of light. Okay, and in most cases, in average, and we know there's just basically the only real important function is the fact that it's charged. That it has a north and south component, and that this is an inverse relationship. Whatever affects protons one way affects electrons the opposite way. And now if you want to believe in positrons and a bunch of other quarks and all kinds of other nonsense, you can go ahead and do that, but they don't play any real role in any real physics or any real chemistry, so they're really not, I'd argue they don't exist as real components of anything. But if you have to include them, you can just understand that whatever effects they have mostly in the form of protons or electrons, and that they really don't do anything in their native form. Anything that can be described in terms of playing any significant role, creating ions, for example, or doing anything else in the atom that could be described as significant. So it's clear that this is what the universe is made out of, this matter stuff that somehow needs to be forced to move somewhere. And the force stuff, the stuff moving the speed of light, that's in discrete clumps, and it clearly affects electrons and protons. And I would argue it always pushes them. Okay, that's all there is. And that all you can do in an environment is create a circumstance where there is push on one side and there's less push, whatever, not less than, but less push on the other side. So one side you're pushing and the other side you reduce the push, and that means the object will move in the direction of less pressure. And that's a pretty simple description. Now that's a leap, I guess, for some. It seems perfectly sensible to me, but whatever. If you can't accept it, then you probably can't accept anything else I'm going to say. Probably. Alright, so I would argue that forces move matter, and so the fundamental idea is okay, so say if I have an electron, we think in terms of kinetics that the little discrete bit, and even when they talked about like Lesage theories and others, they think of these things as hitting and just reflecting, and this thing stops moving, this thing starts moving, this kind of idea of kinetics. And all you have to do is change that a tiny bit, not much at all, to understand that that's not the only way the interaction could take place. The interaction could take place where the little bit of momentum moving the speed of light hits an electron, and it actually sticks to the electron. And now it's pushing it, carrying it, you could argue. And now the electron will move slower than the speed of light, some percentage slower, and obviously the little bit of force now is stuck moving the same speed as the electron. It can't go any faster than what it's pushing. And so in a sense, the electron will move a distance, and the piece of force will move less distance than it would have moved if it didn't hit the electron. So clearly the force, if you were to measure it with some device out here, and you didn't know anything about electrons existing, you would say the force has slowed down because it didn't get to the same distance in the same amount of time, because of it's had to waste some time, use some time pushing the electron a slower speed. So you could say its overall speed was reduced, and that would change its overall momentum, as momentum is the mass, just the substance of the object times its velocity. So it's really just its velocity. Velocity is momentum for the force bits. All the same. They don't have any changing mass. So you change their velocity, that is the time it takes them to get from point A to point B, and you change their overall momentum. So the argument would be is that this model, where the force actually has to move the object, does create it's not a violation of the conservation of energy. It's just a description of how energy is conserved in the sense that you're now moving a piece of matter, which is significant because it does have mass and you're moving it. But the price is now the force. The stuff in the universe that's pushing matter can't push as much matter if it's already pushing matter. So if it's pushing matter, it'll push less matter in the future because it only has so much time it can give away. It can, use up moving matter. And so the idea would be that this transaction, okay, a force bit sticks, moves the object, and then another force hits. So a piece of force from the opposite direction hits. This force reflects, and this force reflects, and this stops moving. It goes back to being stationary. And that would be a simple enough explanation. And then a new piece of force could hit it, and it would stick. And that would move in this direction until some new force hits, and this one reflects, and this one reflects, and it stops again. And so anyway, through this mechanism, you can absorb a little bit of energy, essentially, use it up, occupy it. And by doing that, the system itself, any system that has matter in it, is basically, you could understand that if this force is dense and randomized, that inside any object, the electrons and protons would constantly be moving in a direction. They're going to constantly be making these exchanges with this energy that's constantly hitting them. Just like right now you're getting hit by a bunch of invisible photons in the form of infrared. You're getting hit by radio waves, cell phones, microwaves, all kinds of energy is going through you, and it is affecting you. It is moving pieces of you around. It's just not moving them dramatically enough to cause you any harm. That is, it's not causing atoms to ionize. It's not causing electrons to get kicked out of atoms and create ions that are creating a bunch of chemical reactions that would degrade your function. But they are jiggling. It's all energy. And that energy means that all the time there's matter moving, and it's moving slower than the speed of light. And moving slower than the speed of light means, that the force that moves it didn't get where it was going. It should have been here, and instead it's going to be here. It's going to be delayed. And that delay, is added up, and you keep adding up all these delays, and it means that what goes into an object is a certain amount of pressure, energy, bits, and a little bit less comes out in the sense it's a little less hot. It used up some of the energy to move matter, so there's a little less coming out all the time based on how much movement. Now if I stop everything from moving in here, but I can only stop it by stopping the energy from going in to move it, then I could have, I could fix this equation, because then energy wouldn't get used up going through the matter. But that's the simple equation. So with this simple mechanism, now it goes back, somebody could say it's Newtonian, but it's not Newtonian because Newton didn't posit a theory. It's just another way of understanding how the kinetics on the very small level aren't the same kinetics that we see. I mean, it's not bowling balls and cannonballs and all that kind of stuff. You can understand that the physics of the smallest bits in the universe, again, the electron, you can understand that there could be some other mechanism that causes it to move. It doesn't move because you throw a baseball at it and the baseball transfers its energy, and the baseball is going 90 miles an hour, and then the baseball stops, it hits it, and it loses its 90 miles an hour, and it transfers it to the bigger object, and that just gets divided by the mass, and this turns into 9 miles an hour for the big object. Now, that would be a classical way to look at it, and you could call it classical, but a better word for it would be maybe that's the large object mechanics. Large object mechanics does that. Baseballs do that. But there's no reason to think the elemental universe does that. Just like there's no reason to think that photons are like baseballs. that when an object is releasing photons, that somehow it's releasing something it's producing. So if the object is moving, like you take your hand and you have a flashlight and you move your hand as you turn the flashlight on, it doesn't mean that the photons you're releasing out of the flashlight, okay, are going to go the speed of light, c, plus, okay, the momentum of the velocity of the flashlight. But you can't push them. You can't give them extra velocity. The theory is that what the flashlight is shooting out is energy coming out of a battery, okay, that's trapped inside of the battery, going in some trap, a circle. It's going in a circle or it's going in a square. The point is it's trapped in the battery, and all you're doing is releasing it. So it's like a bird. It's always a hummingbird. It always is flying, and you have it in a cage. And no matter where you move the cage, the bird just keeps flying, and it either turns or doesn't turn based on whether you're moving the cage in such a way where it has to keep turning. And all you're doing is releasing the bird. Okay, so when you're turning the flashlight on, you're not creating something that's going the speed of light. You're releasing something that's already in the battery going the speed of light. It's already force trapped between a couple of electrons. It's already bouncing back and forth between electrons, and you're just letting it go. So you can't give it extra velocity. It only goes one speed, and you release and it goes that one speed. Now, I don't know if you need all that for context, but it's kind of essential to understand that there can be another mechanism for the basic idea of momentum. Something's moving, it hits an object, and what does it do? And I said, I'm just giving you a simple explanation that all you do is change the scenario. It doesn't bounce, it doesn't reflect until some opposite force creates that need. And what it's really going to do is just push the object, so both objects will move through space until they encounter an opposite force that will cause this force to reflect and this force to reflect. And it goes back to being static. And that simple mechanism does take a little energy out of the universe, because the force will not travel the same speed anymore because it's pushing something, carrying something. But as soon as it lets it go, then it's back to its normal speed. I mean, obviously, this reflection would be essentially this object, this piece of force. This line will meet this line, and this force line will meet the reflection that comes off of this one. And so the two forces go back into the universe. They're just going back into the universe delayed. So they should have been here in space, but they're only going to be here in space because they spent some time pushing a piece of matter. Oh, well, you really can't see that at all. Yeah, so that didn't work. My bad. Alright, so they should have been here in space, and they're not because they were pushing matter. These are just the lines pointing out that this one will be realized back into the universe as the reflection of the counterforce, and the counterforce will go back to the universe as the reflection from the original force. So the counterforce isn't going to lose any momentum, really, not much. It's this force, the one that was pushing the matter, that moved it, that's the one that loses a little bit of its momentum. So anyway, that explanation explains why matter moving, and it's always moving, the little bits, matter jiggling, just moving back and forth, is consuming energy out of the external universe, in the sense that the outside is hotter, okay, in a sense of force moving, than the inside, because the inside is moving matter, and moving matter means you're moving slower, and so that explains why there's a differential, and explains why anything sitting outside of a bunch of matter, there's a bunch of matter, a bunch of electrons and protons being jostled about, anything sitting outside of that is going to be seeing, feeling, experiencing more energy this way and less reflecting off the object. And therefore, they'll be pushed into it at a rate completely consistent with how much mass there is. How many electrons and protons will decide how much gravity is being created. All right. So we'll move on to the next bit of whatever writing. Ugh. All right. Bending space in 3 dimensions is identical to creating evenly distributed higher external spherical pressure. So I don't know. You have to use all these extra words to point out that we're talking about the fact that things go spherical is just an implication of this idea of even pressure. And the more uneven the pressure is from the inside to the outside, the more likely it is to be spherical. The more gravity it's creating as a consequence, the more... So gravity is basically, you could just say, when you create gravity, you're just saying, I'm delaying a force. I'm consuming a little bit of its momentum. But like I stated before, if you had a sphere and you have an external force outside of it, and the force gets slowed down a little by moving little bits of matter, you could understand that there's always going to be a little less coming out than went in at any one moment, because of this fact that a little bit of the energy is being used up moving the matter around. Yeah. All right. An unevenness in thermal equilibrium. So that's one way of looking at it, as heat. So the fact is while you're heating, the object, we think of heat as being the actual electrons and protons moving, or the atoms themselves moving. So they're jiggling as well as the little bits are jiggling, and all of that jiggling or being pushed around, moving, is heat. And so it's the fact that the object is hot, that it gets hot because it has matter in it. It means it's sort of used up the thermal energy. The energy to make heat is out here in the universe, and that energy gets realized, gets converted into real hotness. That is what we consider hot, which is an atom or an electron or proton moving. And so this energy gets converted into some kind of real heat, and that real heat is the consequence. The result of that is you don't have as much heat to give back, because you have heat in here. You're moving electrons and protons, and therefore you can't give back to the universe as much potential to create heat as you brought in. So many ways to say this. Let's see. So more energy density on the outside than the inside. So I've sort of made that clear, that speed is everything to the energy of the system. And so if I slow the speed down, I slow down the number of possible interactions. So that's pretty simple, right? I shouldn't have to explain that, but interactions are the event of the universe, is the interaction of force hitting matter. And you have less force hitting matter, the more force hits matter. So the more it hits matter, the more this event happens, where an element of force hits an element of matter, the less energy there is for that to happen some more, because that event uses time. And so now there's less time for more of those events to happen. And the less that happens, the more these force bits get. The farther they progress, they have a place they're going in the universe, so to speak. They're going somewhere. And essentially, the more of these little obstacles, the more times you put an event in here where they hit an electron, that's going to slow down their progress, and they're not going to get as far through their task in a given amount of time, the more times they have to move an electron. The more load they carry, the less potential they have to carry loads in the future, because they have less of a future, essentially. Sort of. It could be stated that way. Alright. So these are, like I said, talking points. I'm going to eventually attempt to write them into some kind of paper, but I'm just so bad at that right now. I just can't. Somebody who likes to write, if you want to, take what you got out of what I said and see if you can write it into a paper form. Just describing the essentials. That it's not violating some fundamental rule to understand that the small universe works a little different than the big universe, and that this simple rule explains why there is gravity and why the other forces work the way they do. But anyway, all right. Force or force bits lose some momentum moving. Okay, now be moving matter. I gotta find a better way to scroll this. Alright, so clearly I'm just arguing that these bits are in the universe, just bits of force, blah 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 blah, and the more matter I put in here, okay, the less energy the force is going to have, because it's going to be spending a lot of time carrying the load of moving matter. I guess another feature I'll just point out would be this is another new thing in a sense. Okay, I've pointed out how the polarization of, say, regular light, okay, a regular nanometer, 500 nanometer light, visible light. If you took that light has a polarization of 500 nanometers. So it's it's tall. Okay, so if you think of it as a wave, it's a very tall wave. It's very big. Thousands of atoms, theoretically 1,000 atoms could fit in the polarization of the light. But when you get to smaller and smaller, like X-rays, well, then you're down to 10 nanometers for medium, I guess, X-rays. I don't know whether they're hard or soft at 10. But that's still maybe 20 atoms worth. Okay, but if you get to like gamma rays, you could get to a point where, no, 1 atom's worth. And so you could actually produce a gamma ray from a single atom, because the polarization is within the size restraints, okay, of the atom. So the point is that the visible light always has to be coming from more than 1 atom. It has to be coming from the elements of the photon have to be coming from a sequence of events that takes place in matter. And the sequence of events is to release the elements of the photon in sequence, and that's the frequency. So the frequency is being created by the release time, and more than 1 atom is creating it, and that's creating the polarization. But gamma rays could potentially be caused by a single electron jiggling and causing the effect, because the polarization is very, very small. That's just FYI, kind of a added bonus. But that has implications for exactly what might be creating light. Is actually, it all starts as gamma rays, and it's just the frequency is reduced by just taking some of the elements of the gamma ray out. So the gamma ray would be a lot of elements, and what you're doing is having interactions through the process of the energy being transferred from atom to atom, and the process of transferring just takes some of these elements out and widens the frequency. But anyway, side subject. Alright, so back to where we was. Force or force bits lose some momentum moving matter. So that's the simple one, and that's the cause of the deficit that is gravity. Alright, Oh, I can scroll it in here. I didn't know I could do that. That's kind of interesting. Oh, I'm not doing it in there. All right, force trapped in matter atoms equalizes to the external pressure. So the atoms themselves are, functioning in this force, and it's part of the reason why the charges and all of this stuff balances out, and it's all an equalization of pressure. So you could argue that while matter is being jiggled, that it has to probably expand just because of positions. There would be a circumstance where this object, instead of being here, is here because it's getting jostled, and this object could be over here because it's getting jostled. That means there would be energy between it, and then be pushing it back the other way. And so everything would have to expand a little bit with heat. And that's what you see mostly, except for the rare exceptional atom that doesn't obey the rule, but the tendency is that heat will cause expansion, and expansion is a reduction in density, but that's sort of the pushback you're getting from pushing the force in and not letting as much force back out. Is sort of the idea that the pieces are moving, which means they're expanding a little bit in their relationship to each other. So it's kind of a subtle point, but threw it in there. All right, the momentum loss is in the form of a loss in velocity. So that's the simplest way to understand it. So the force bits don't lose any mass, of course. They're just losing time, and time is velocity. I've sort of said it enough times. Alright, bits of matter move slower than the bits of force pushing them. So that one's kind of obvious. That goes like right back to the beginning. And that is sort of the beginning is the end. Let's end with the beginning. So it's a simple explanation for how the same universe is creating all this stuff. I guess I'll throw it in here just because I'm here and I can do it. So I'll do it one more time. This idea that I'm arguing that it's just 2 plus 2 plus 2 physics. That there's just two kinds of force. Plus and minus force, if you want to call it that, or north and south force. Doesn't matter. So we can call this south, and we'll call this plus, and we can call this minus, and we'll call this north. And that completely correlates to the fact that there's two kinds of charges, the plus charge and wrong. The plus charge, the proton, and the minus charge of the electron. So mark those. So two kinds of force, two kinds of matter, and there's two kinds of interaction. So this really doesn't affect gravity in the sense that the two kinds of interactions are basically one interaction does exactly what I described previously. The momentum comes in, it pushes the object. Okay, the object goes to a new location. The force, stays with the thing it's pushing until there's a counter force. So till it encounters another force, it just keeps pushing it slower than the speed of light. Now, I mentioned gamma rays before. Well, the idea would be is if some other force hits this in this direction, they basically add. So if it's going 1/4 of the speed of light, well, if there's two of them, that is, now you could understand it that it has one stuck to it, and now it has another one stuck to it. So let's say one came in this way with a vector in the same direction. It would just move behind. These two would be the same, and they would just push behind each other. And that would be the formation of, say, something like a gamma ray, something with a very tight frequency, because the only way you can reflect that object is to essentially hit it with another ray or another force coming at a very tight frequency, because then you'll get reflection, 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 reflection. You'll get this, you could pile up 6 or 10 of these, and this one will reflect on the next encounter, and then this one reflects, and then this one reflects, and they'll all end up reflecting from the same point. And that would be how you'd create something like a gamma ray. All right, so so there's just two interactions, as I made it clear. So one interaction is the same force hits, and it moves the object, and then it's reflected eventually at some future location. It will be reflected. And then the second interaction is that the opposite force hits, the positive hits negative, or negative hits positive, or north hits, I don't know why that's not writing, crud or something. So you can still see that, right? Yeah. So it hits, and what happens is the force merely changes in what dimension it leaves. So it can leave in, left, right, or up or down, and so it changes what dimension it leaves in. And that change in dimension doesn't cause any momentum, so this object doesn't move. And by just having that simple rule, so one interaction is benign, doesn't cause any movement, one interaction does. So obviously the two things are doing exactly the opposite, and that's why it doesn't affect gravity any. So as long as all the atoms are not polar, that is, they're not in any kind of condition where you cram an electron right next to a proton and create a little mini magnet. And if those weren't all lined up, then you got no problem. And like I said, the model does create everything that you need for magnetism, in the sense that, as I've explained, the magnet would be a simple, just obeying that simple rule, those two options. The idea would be is that the magnet will just take the universe as it sees it, okay, which is a lot of stuff comes in that's mixed. So you can just think of it as purple, the two kinds of force, well mixed. The magnet sees that come into it, it comes into it, and what happens is the red side will take all the blue energy and send it that way, and the blue side will take all the red energy and send it that way. And so you'll have a bunch of red reflecting, a bunch of red coming from the blue end out the red end. Then all the red that hits will just reflect, because the momentum exchange. So once the thing moves to another location, it moves, and then it reflects. So all this will be red at one end and it'll be blue at the other end. So the magnet is just a filter of the force that exists in the universe, the same force that creates gravity. And you're just creating a mechanism where you filter it. And so you take purple, turn it into red and blue, and now any other object that is polarized, that is, has a red end and a blue end, will be able to see the red and blue. They'll see the difference, and they'll turn and move commensurate to the fact that it's going to be hit by forces that move it, that are now segregated, separated. So that's all you need. Two kinds of force, two kinds of matter, just the electrons and protons. The neutron is a composite of an electron and proton, and that also explains the strong force, by the way. See, it all fits. I mean, there's no way this can't be the right answer for that reason alone. How could this work for everything? I mean, it answers every question. I mean, no matter what thing you shove at it, it explains it. So the big mystery in physics is, why are protons allowed to get so close to each other in the nucleus? They should be creating this hostile reflections. The closer you bring it, see, this is the ping pong ball argument, ping pong paddle. The further away they are, you can see less interactions, right? The closer they are, right, I double the number of interactions. The force hits 6 times here. In the same amount of time, it only hits 3 times here. So you can understand this is obviously more energetic to the matter. The matter is getting pushed this way and this way 6 times instead of just 3 times in the same amount of time. So obviously proximity in this model means pressure. So how do protons get so close together? Well, the simple solution is the neutron provides the answer, because the neutron, we'll just draw it as an electron and a proton. Well, all I do is add another proton. So this is a neutron, this whole thing. And then this would just be an added proton. And with that simple mechanism, you just do the math here, so to speak. You say, well, what happens to a red force? Well, it goes out one of these directions from the blue object. And what happens to a blue force? Well, the blue force ends up going out one of these two. And so nothing can reflect here. Any blue that comes in this way reflects this way. It can't get to the electron. Any pink that comes in this way reflects that way, so can't get to it. So clearly nothing can get in between here, and therefore the protons can get really close to the electron, because the pressure between the two protons will be very low, and everything will be leaking out of one of these objects, and so nothing will exist here. Here and here will be very low pressure. Oh, you can't see that now. Okay. Well, I do have to remember I'm not allowed to go up and down much. So anyway, so I think that's probably completes the subject, but I'm just saying, so it explains what the strong force is actually a weak force, because all the force is being dissipated. It's all being redirected. And by redirecting it, it's neutralized the pressure. And so simple explanation fits, works. Now you don't have to account for a bunch of fake energy. See, the strong force is something they can't explain, because they have to say there has to be some external pressure forcing these things together, when now it doesn't need to exist. The electron provides the mediation to get rid of the pressure. Alright, so probably enough of a video and such. So till the next time, and so forth and whatnot. Yeah, I think that's probably enough. I could put this back on one more time. Yeah. No, that isn't it. This must be it. Yeah, that's it. Oh, yeah, that's not it. Yeah. That's it. And I'll get rid of this. It's annoying. Yeah, that's quite pretty. And such. So, yeah, no commentary from anybody worth anything. Not getting any counter arguments. Not getting links to the well-done physics videos on YouTube. Not getting any takers for the $1,500 I'm offering to anyone with 100,000 subscribers to debunk anything I've said. So I'm winning, but it's it's just this very one man at a time kind of thing. Because obviously reasonable people are at least paused, because they're not making obvious arguments. Any useful counter arguments, besides insults, they don't have anything. So yeah, but whatever. I can only provide my end here, right? I mean, you all want to be stupid humans, I can't stop you. I'm just saying there's a much simpler explanation than the wooey answers of bent space, time, and silly wave mechanics. There's a simpler explanation. You don't need those two silly explanations. It's not even that you don't need them, they're just so overtly silly and overtly incomplete, and they really don't answer the evidence. So anyway, until the next time.